So now we are going to see the experiment that is going to be conducted on this variable speed air blower. So in case of variable speed air blower, so this is the experimental setup that is meant for this variable speed air blower. Here we have a motor and a blower. So this blower, which is connected with a manometer, U-tube manometer, and here you can measure the static head with the help of the change in the liquid level in manometer, and then that is a that is a drum, and from there, so you can you have an inclined manometer. So from that you can measure the value of this delivery head. So the angle that is inclined in that delivery head is, for that manometer, is 30 degree. So you can measure the value of HD, that is delivery head. So the connection is like this: motor, so with a blower, the blower is connected with a pipe, and that pipe is connected to a U-tube manometer, and that pipe is connected to a drum, and that drum is nothing but the delivery, and then the delivery is connected to a inclined manometer. So that is inclined at 30 degree, and then in front of the drum you have a orifice plate. So initially the orifice plate is kept there, and the diameter of the orifice is also measured. And now here you can see that, so this is a variable speed air blower. So what is the aim of this experiment? So here you are going to conduct a performance test on this variable speed air blower, and you are going to draw the performance characteristics, and then you are going to also verify the Fan's law. So if you want to find the performance characteristics, what are the performance parameters? Here you have. So initially you will measure the density of the air, and then you will measure the air power, then this input, then this static. So all this you are going to measure with the help of the thing. So now you are going to change the speed initially. So here the rated speed of this blower. So you want to know the specifications of this blower. So it is a forward curve blower, and then the density is given here in the specification, and then the discharge, how much of air is discharged, is also given in the specifications. So now you are going to change the speed. So what is the rated speed? So here you can change the speed from 1750 to 3750 rpm. So then, and also you have to measure the energy meter. So for 5 revolutions, what is the time that is taken from the energy meter? You have to measure the value, that is time for 5 revolutions. So all these measurements has to be conducted in this variable speed air blower, and that is in experimental part, and then you have to go for the calculations. So this is the setup that is meant for this a variable speed air blower. And then now you are going to do what are the parameters, or how you are going to take the values. So that is in this, and for that what are the things that are required? So a tachometer is required to measure the speed, or otherwise you can go for a stroboscope. With the help of that stroboscope, how that stroboscope works? So it works on the principles of relative motion. So if two objects which moves in a particular direction, so you can, if they move at the same speed, so you can easily measure the value of that speed from one of the other, so that you can find the other speed. So with that principle, that is relative motion principle, so you can find that speed with the help of this stroboscope. So a stroboscope is required to measure the speed, since you are going to vary the speed from 1750 to up to 3750. So just a 5 set of readings is enough to conduct this experiment. So you can see that experimental part, then you can move on to the calculation part. So first you can see the experimental part. So initially you have to switch on this blower. So then you have to start this stroboscope. So this stroboscope, you can see that. So the power on is there, button is there, and then the range is there. So you have two ranges, one is low and other one is high, and a fine adjustment knob is there, and this is for the fine adjustment of this. So you can see here, so when you on this, so you can see the light. So if you have to show this, now the range is at a high range. So for low range you have to go there, and for high range here, so you can see that. So what is the speed? That is, so now you are going to increase the speed. So with the help of that, so now you are going to measure the value of the section, that is a static head. So that is H1 and H2. So then you are going to measure the value of the delivery. So now, so you can, the speed is determined, and then for this speed you are going to measure the value of this H1, H2 in the static head, and then in delivery head H D sin 30. From this blower, so a manometer is connected. This is a YouTube manometer. So from this you can measure the value of this. So you can see here the H1 and H2. So this difference can be measured. So you can see the scale. From that scale, it is here. It is around 39.5, and here it is around 62.5. So you have to measure the difference. So this 62.5 minus 39.5. So you will get the value of this static head. So now, so this is the drum. So this one is for the delivery, and from the delivery a manometer is connected. This is an inclined manometer. This manometer, it is inclined at an angle of 30 degree, and you can see here, so the inclination, so HD, so the delivery is around 4, so that is around 4 centimeter. This 4 into sin 30 degree. So you will get the value of this delivery head. So static head is there, and you will measure with the help of U-tube manometer, and this delivery head is here, and this delivery is measured with the help of inclined manometer. So from this, so then we have to move on to the energy meter. So from energy meter, for 5 revolutions you have to find how much of time it took for this 5 revolutions. So you have to find that. So now, so far we have measured static head, then delivery head, and then now we are going to find for 5 revolutions how much of time taken. So this is energy meter. From this energy meter you can see that, so 1 kilowatt hour is 300 revolutions, and you can say, so for this 5 revolutions what is the time that is taken. So now this red mark is taken as the initial point. Yes. So for 5 revolutions, what is the time? The 1 revolution, two, 3, 4, 5. So this is the time taken for these 5 revolutions, and for that, so that T is considered for that 5 revolutions, and you have to substitute in the formula. So far, so we have measured the static head, then delivery head, then the orifice is already known to us, then we have varied the speed. So the speed is now around 1750 rpm, and then so we measure the value of this energy meter, that is for 5 time for this energy meter for 5 revolutions. So these are the things which you have to repeat for further increase in speed. So you have to increase by either by 100 or 200 rpm. So from 1750 to 2000, maybe 2000 or 1950, then 2200 and 2400 and 2600. So 5 set of readings are enough to find the performance characteristics, and also then, so with the help of that we have to find the value of the we have to verify the Fan's law. So that has to be verified. So that is the aim of our experiments. So one is to determine the performance characteristics, and the second one is to verify the Fan's law. Okay, so same set of reading has to be repeated for further increase in the speed. So far we have seen how we have to measure the values in the variable speed air blower. So and from that we are going to find the performance characteristics of this variable speed air blower, and then we will find the Fan's law. We are going to verify the Fan's law. So from this performance test, so first you have to form the tabulation. So in the tabulation, initially we have measured the static head with the help of U-tube manometer, and then delivery head with the help of an inclined manometer. So that static head readings are tabulated here. So the and its difference is found out. So that is found out in case of water column. So this HW, so it refers to water head. So that is static water head and static water head, that is H1 and H2, and the difference between H1 difference H2 is found out. So that is HS, that is static head. So everything is measured in terms of centimeter. And now the delivery head. So the delivery head, so we have found out we know that the manometer is inclined at 30 degree. So that HWD is found out, and that HWD sin theta is found out. So then that HD, using the formula we have found out this HS and the HD. So then the energy meter reading, from that energy meter for 5 revolutions, so we have found out the time. So that is for various speeds from 1850 to 2450. So we have found out the energy meter readings. So we have found out how that energy meter rotates. So for 5 revolutions, so what is the time taken has been measured. So with that, so we are going to find the other performance parameters. So like mass of the air, then air power, then input power and static efficiency. So all these we are going to find out, and then initially the discharge of the air. So all these we are going to find out. So apart from this, we are going to find out the value of the, that is we are going to verify the Fan's law. So what does Fan's law says? That discharge is proportional to the speed, and then this static power, so it is proportional to, or static head is proportional to the square of the speed, and this input power is proportional to the cube of the speed. So all this has to be verified, and then we will conclude whether the verification is right or not. So now, so after this tabulation, so you have to write the readings for this static head, delivery head, then time, and then the revolutions. So then all the other has to be found out with the help of the formulas. So first one is density of air. So it is measured with the help of this, or it is determined with the help of this formula. So Pa divided by Ra into Ta. So this Pa is nothing but the atmospheric pressure. So that is 1.0135 into 10 power 5, so Newton per meter square. So divided by Ra is, so that the constant characteristic gas constant is 2.87 or 0.287 joule per kilogram Kelvin into this atmospheric temperature. So that is 303 Kelvin. So all this, from this you can find the value of the density of the air. So that is 1.165 kilogram per meter cube. Then the delivery head, with the help of this formula, HD is equal to, HWD is known to us. So into density of water by density of air into sine theta, so that you can find out. So that is 12.5 from the reading. So then into 1000 divided by 1.165 is the density of the air into sine 30. You will get the value of this delivery head in terms of meter of air. So then static head. So that HS is HWS is known to us. It is found out in terms of centimeter into density of water and density of air. So the centimeter is converted into meter of air, that is HS is equal to 68.66 meter of air. Then actual discharge QA, so that is determined by CD is the coefficient of discharge into A, that area of the orifice, that is known to us. So into velocity, that is root of 2g hd into 60. So this QA is the product of all these terms, that is CD, the coefficient of discharge, then area of the orifice and the velocity. So QA, so is CD, that is coefficient of discharge is 0.61 into area is pi by 4 d square into this V, that is velocity is 32.44 meter per second into 60. You will get the discharge, actual discharge in terms of meter cube per minute. Then mass of the air, so density rho A into QA. So if you multiply these two, you will get the value of this mass of air in kilogram per minute. And then the air power, so M, you know the value of the mass, and then the gravitational constant and static head divided by 60 into 1000. You will get the value of air power, so which is one of the performance characteristics. Then input power, so N, number of revolutions into 3600 into 0.6 divided by T. For that 5 revolutions, what is the time taken into energy constant, which is given in the energy meter, that is 1 kilowatt hour is equal to 300 revolutions, that is 300. So one India, this input power is equal to 1.09 kilowatt. And then static efficiency, so eta S is equal to, we know the value of air power and input power, the ratio between these two, that is air power and input power, if you multiply it by 100, so you will get in terms of percentage. So that static it is around 11.21 percentage. So now you have to verify the Fan's law. So before that you have to draw the performance characteristics, and apart from that you have to verify the Fan's law. So as I already told you that discharge is proportional to speed, and static it is proportional to square of the speed, and input power is proportional to cube of speed. So you have to verify all this. How we have to verify? So we have to verify with the help of a graph. So now we are going to verify Fan's law. So we know that, so what is Fan's law? So you have three statements in Fan's law. So one is discharge is proportional to the speed, and then this static head is proportional to square of the speed, then this input power is proportional to cube of speed. So now you have to verify these three. So how you have to verify these three? So one is, so you have proportionality symbol in all these three. Suppose if you go for Q is directly proportional to N. So that is, you are going to draw a graph between that speed and this discharge. So for that you have to remove this proportionality symbol. So how you have to take log on these two sides. So to remove this proportionality symbol, and you have to introduce a constant, either it may be C or K, whatever may be. So if you take log on both sides, that is log base EQ should be equal to, so if you want to remove this proportionality symbol, you introduce a constant, that is C, into log base E N. So this log base E Q divided by log base E N should be equal to the constant. So this is nothing but this, if you want to verify this in graph, so this is nothing but, so y is equal to mx plus c. So from this, if you go for the first derivative, so that is dy by dx, so this will be equal to a constant. Okay, so you have to prove that dy by dx is equal to constant. So that dy is nothing but log base eq and dx is nothing but log base en. So this dy by dx, so if you get a line like this, if you get a graph between, if you draw a graph between this log base en and log base eq, so you will get a curve like this. So a straight curve. So you have to now, you have to find the value of this c, but you have to assume this c. So let c be 1. So initially we assume that the c be 1. So that is log base eq by log base en is equal to 1. That is dy by dx. So you have to take any values on this graph, on this line, so such that you have to form a slope. So let this be dy and this be dx. So you have to make an adjustment on this line or this graph such that dy by dx should be equal to 1. Okay, so now we are going to the next one, that is static head. So that is Hs is proportional to square of the speed. Similarly, you have to adapt the same procedure, that is log base EHS. Log base EHS is equal to that 2 into log base En. So this 2 will come to this side. So log base EHS divided by log base En, so that is equal to 2 into, you are introduced some constant. So that 2 into c, already we have assumed that as 1. So 2 into 1, so that becomes 2. So log base EHS divided by log base En is equal to 2. The same, so you have to draw a graph between log base En and log base EHS. You have to draw a graph. So with that graph, so you will get a line like this. So this dy by dx, so this is dy and this one is dx. So you have to adjust, so in such a way that this dy by dx, so nothing but log base EHS divided by log base En should be equal to 2. So you have to adjust like that. So then that means you have proved this Fan's law for the first and second. For first it is equal to 1, that is log base EQ by log base En is equal to 1, and for the second it is log base EHS divided by log base En is equal to 2. And similarly for the third one, So that is log base E IP divided by log base E N should be equal to 3 into C into, so 3 into C. So that is log base E IP divided by log base E N is equal to 3. So this is already assumed as 1. So you draw a graph for the same, that is log base E N and log base E IP. So if you get a line like this, so you have to adjust and you have to mark as dy by dx. So that is the slope dy by dx is equal to log base E IP divided by log base E N is equal to 3. So if you prove all these three, that means you have verified the Fan's law. Before I have told you to verify the procedure for this Fan's law. So now we have drawn the graph. So with the help of the values that we got for input, that is input power, then static head and discharge. So with that, so with the speed, so we have drawn the graph. So and so these are the graphs. This is the way in which you will get the graph. So for this input power, then static head and then discharge head. So you will get a straight line, so which is inclined upwards, and then static head versus speed. So these are the performance graphs. So if you draw graph between speed and static head, so you will get a curve like this. Then speed versus actual discharge, so you will get a curve like this. And speed versus static efficiency. So this static efficiency is the result which we are going to find. So that is the static efficiency of this variable speed air blower. So then speed versus input power. So if you find all these graphs, so initially, so we have measured one is from the static head with the help of YouTube manometer. We have measured the difference between this water column and we find the value of static head, and we convert that into that water column into meter of air. And similarly for the discharge head with the help of a vertical manometer which is inclined at 30 degree. So with water column, so we convert that into meter of air, and then we find for 5 revolutions of this energy meter value, and with that, so we found that discharge and all. So apart from that, we found this performance characteristics like air power, input power, and then mass of air. So with all this, then we have verified the Fan's law. So all this has to be found out, and at last the result has to be given like this. So the test on this variable speed air blower is conducted, and the characteristic curves are drawn, and also the Fan's law is verified. So the static efficiency, here efficiency refers to static efficiency of the variable speed air blower is given as 14.23%. So with this, so that variable speed, the experiment test that is on this variable speed air blower, it comes to an end.